All right, good afternoon, everyone. Welcome to the fourth life lesson. This one is on parametrics, which is the extension 1 component to Locus and parabola. So let's get started. So if you haven't seen any of our live lessons before, you can definitely go check it out on our website. So some of the previous ones have been uploaded. We've done some on geometric application of calculus, so like curve sketching and maximization and minimization problems. And last week we did the two-unit component to this topic, which is the quadratic functions, locus, parabola. So some of the more basic stuff. So this week is the extension stuff. It is a big jump in difficulty, so hopefully everyone can follow. As always, this will be uploaded after the live stream, so you don't have to try to catch everything. You can always go back and review the recording of the video. So in terms of the format and what to expect, there will be a presentation on parametrics today for 1 to 1.5 hours. We do have a Q&A that's happening over at our Facebook group, so feel free to join. So Facebook group, if you type in Pinnacle Live Discussion Group, this will come up. We use that to communicate with students, let me just flick back to that. We use that to communicate with students, and if you have any questions at all, feel free to post up there. So right now we're still trying to grow the numbers, but we definitely welcome any questions, suggestions, any feedback at all. That will be very much appreciated, and or even just a shout out if you're finding these live streams very helpful. Please let us know so we know to keep it going next term as well. So there will be a chat box next to the live stream. So if you have any questions, you can also interact with us over there. And feel free to, so join the Facebook group. And as always, this is very new for us. So we are still trying to learn and find the best way to deliver the content. So please let us know if you have any feedback at all. A little bit about me. I am the co-founder of Pinnacle Coaching College, so I mainly teach maths. So all the material here is written by and the program is directed by me. I personally teach both Extension 2 and Extension 1 Maths at Pinnacle, and my students historically have always seen amazing results. So hopefully I can use some of that knowledge in training all these students in the past and share a few of the techniques with you. But at least for it is the key differentiate. We will talk about the main equations that will be examined, what to make of the reference sheet, and then sort of go on from there. All right, so what exactly is on the reference sheet? So basically, this is an exact sort of snapshot straight from the reference sheet. So you have the Cartesian form, the parametric form, x equals to 2at, y equals at squared. So remember what the parametric form is. The parametric form literally is, let me just draw this. It tells you the coordinate of this graph for any given parameter value, so the t value. Okay, so if you start in t equals 1, for example, it will tell you the exact point you should be looking at. And at that point, the tangent has that equation, yeah? So y equals to tx minus at squared, and the normal being a line perpendicular to the tangent. Okay, we'll have this equation. Then there's also the Cartesian forms, which is basically using your standard Cartesian coordinates, so x1, y1, or maybe just a number. So an example of a Cartesian coordinate would be just 2, 3, for example. Okay, and the chord of contact. So what a chord of contact is, it's rare that you have to derive this in the exam. And historically, before the reference sheet, I would say generally speaking, it's not heavily examined, if examined at all, mainly because it's not a formula that a lot of people remember anyways, and you don't use it that much, and it's applied in a very, very specific scenario. So now that it's in the reference sheet, the context is probably going to come up is you just have to apply it, which is not that hard to apply. So what you need to know is the point that is external to the parabola. And from that point, got tangents, okay? And then the line joining the 2 points of contact is the chord of contact. So that's this equation there, okay? So that's that line there. All right, so that's it. It's a very, very specific situation. So if the situation calls for it, all you need to know is that external point, and then you sub it in. You will also need to know the focal length and sub that in, and you'll get to the equation. Now, I'll say there's a bit of, just from an exam perspective, right? A lot of the materials you'll be getting from your teacher, and also a lot of the past exam questions that you'll see in this area was written prior to the appearance of the reference sheet. So the reference sheet is a very recent phenomenon. It's only been the last 2 years. So prior to that, pretty much everything, if it has to be used, it will be derived as a part of the question, or sometimes they will just tell you, this is the equation, just go away and use it. You don't need to prove it. Okay, so nowadays, because of the reference sheet, they might be a little bit less explicit about that. So I'll sort of talk about it when I go through some of the questions later. But what you're finding in the more recent questions is sort of implied in the question, you need to know what the tangent or the normal is, and that's kind of what you just take straight from the reference sheet. You don't need to derive it unless the question specifically asks for it. But at the same time, it's also sometimes a little bit difficult because it doesn't say, oh, here's the equation. You can assume it and go find it. So it's not as obvious in terms of the pointers. So that's roughly it. So having said that, yes, the formulas are on the reference sheet. It's still important that you're able to derive it, because they can absolutely ask you to derive it as a part of the exam. So let's have a look at how we firstly derive the equation of the tangent in the parametric form. So let's start with visually what we're working with. I find that especially in parametrics, it's important you understand what you're working with. Quite often when students ask me questions in this area, the first thing I ask them is, have you drawn a diagram? And the answer is no. Then I'll say, well, you have to draw the diagram. Otherwise, how do you know what the facts are? And quite often it's really obvious after you've drawn the diagram. Okay, so that's my first little hint. But for something like this, yeah, just so that you know. So we're looking for a tangent that is tangent to this parabola. So this parabola is x squared equals to 4ay. All right, so in any tangent process, right? So the first step would be find the gradient. So to find the gradient, you take the standard form. So x squared equals to 4ay. Make y the subject. So y dash. So differentiating x squared is 2x. So it's x squared on 2a. Okay, then you are finding the gradient specific to that point. So don't forget to sub x is equals to 2ap into this. So the gradient is p. Okay, so that's more or less it. I'll go ahead and complete the equation first, sort of another way to find the gradient as well, just mainly for the more advanced students. I mean, some of the more tricky questions can use the second method, but I'll show you later. All right, so the second step is to find the equation. So to find the equation is quite simple. We are using the point gradient formula. So point gradient formula. Yeah. So the gradient is p. The point is 2ap, ap squared. So subbing that in. Expand. And then I'm going to move that to that side. Okay, that's it. All right, so that's how you derive the equation of the tangent. All right, nice and simple. Now, as I mentioned before, as a side note, you can do the gradient a little bit differently. So the gradient can be done through parametric differentiation. So if you take the parametric coordinates and differentiate it with respect to p, so that's just 2a, and dy dp is 2ap, okay? And we combine that together using the chain rule. So dy dp is 2ap, dp dx is the reciprocal, so 1 on 2a, so that's p. Okay, so you get to exactly same result. So this is handy, especially if you come across a question where you only have the parametric form, you don't have the Cartesian form, then you won't be able to do that type of differentiation, so you can do it parametrically. Okay, I mean, alternatively, you can always recreate the Cartesian form by eliminating the parameter and just differentiate that result. That works too. All right, so to summarize, how do you find the equation of the tangent? So you go through and find the gradient by differentiation, subbing the point you're looking at, and then use the point gradient formula, find the equation. So another very common equation that we'll use is the normal. So let's start by going through, well, what exactly is the normal? Okay, so going back to the standard stuff, so 2ap, ap squared. So got the tangent from before. So normal is the line that's perpendicular to the tangent going through the same point. Okay, so just like before, the first step, we need to know the gradient. So how do we find the gradient? Well, we already have the gradient of the tangent from before, right? So the gradient of the tangent was p. Then the gradient of the normal should be negative reciprocal of the gradient of the tangent because they're perpendicular, so minus 1 on p. Okay, all right, so then second step is to find the equation. So to find the equation, we go through exactly the same steps, apply the point gradient formula, gradient being minus 1 on p, point being 2ap squared, and then subbing everything in. Now, I find that this topic gets a lot of students, not because it's hard. If you think about it, I'm going to multiply the P across here. If you think about this, right, this is just pure coordinate geometry. Yeah, all the equations we're using is nothing fancy. But why it trips up a lot of students is because it's got a lot of pronumerals in there. So it's not numbers, pronumerals. And I think that's where it challenges a lot of students, having to operate in pronumerals and then try to, I guess, separate what is a variable away from your constants and sort of keeping that in mind. So with practice, I'll say generally this is not an incredibly difficult topic. You just have to sort of see past the algebra or the variables that appears in the question and just really break it down as a coordinate geometry problem. All right, so that's it in terms of the normal. So all I've done is done it in general form. So I multiplied the P across, expanded it out, and then move the negative x to the left side and then move that to the right side. You get that. And that is it. So another very common one that comes up, this one doesn't actually sit on the reference sheet. It's the chord. So while it's not on the reference sheet, to be honest, it's not incredibly hard to derive it anyways. So let's say we have 2 points, 2AP, AP square, and another point Q, 2AQ, AQ square. And we're trying to find the line joining these 2 points. Okay, so the standard steps to finding the equation of a line is gradient and then point gradient formula. So start with the gradient. So this time we've got 2 points, so we're going to apply the gradient formula. So y2 minus y1 is equal to x2 minus x1. So apply that to those coordinates. And then factorize. And then factorize the difference of 2 squares again. Cancel. That's it. Okay. And then second step, find the equation. So how are we going to find the equation? Point gradient formula yet again. So the gradient is P plus Q on 2. The point, just pick one of them. So let's say 2AP, AP square. And we are shoving it into this formula. All right, so let's stick everything in there. Okay, so now with expanding this, there's a little bit of skills to this, just knowing not to fully expand this. So all I want to do is multiply this whole thing to the first term and then multiply this whole thing to the second term. So we've got P plus Q on 2x minus P plus Q on 2 times 2AP. All right, so that's going to be intact. We're not going to touch that. And then we're going to simplify this a little bit. So the 2 cancels out. So you have AP times P. So minus AP squared. And then AP times Q minus APQ. And then you see how, so I'll just copy the left side down. You see how minus AP squares on both sides, so they can cancel out. That means our equation is simply that. All right, so that's it. That wasn't too hard. So if you think about all three basic equations so far, it is literally find the gradient, point gradient formula. That's all I've used. How you find the gradient, you can use calculus if it's tangent and normal, or in this case, I simply use the gradient formula. All right, so let's take a look at some of the exam questions in this area. So usually there's a locus component. A lot of the exam questions in this area are sort of building on the basic stuff. All right, so in this first exercise, we've got 2 points sitting on the parabola x squared equals to 4y, and we're given that PQ subtends a right angle at the origin, and we want to show this result. First thing, let's sketch this thing. All right, so we've got 2p, p squared, 2q, q squared. Okay, and we're given that the interval PQ subtends a right angle at the origin. All right, so that's the unique information to this question. So let's see if that can get us the first result. So how do you use the right angle? You want to use the fact that the gradient of these two lines will be -1. All right, so since angle POQ is 90 degrees, then the gradient OP times the gradient OQ should equal to -1. So the condition for being perpendicular. All right, so let's figure out what they are first. So gradient OP is just purely applying gradient formula here. So it's P on 2, okay? Now, obviously, OQ follows a very similar formula. So what you can do is just, you can go similarly, it's the same thing, or pretty much you can skip to the step that's just Q on 2. Okay, all right, so therefore P on 2 times Q on 2 is -1 because of the perpendicular condition. So PQ on 4 is -1, PQ is -4. That's it. So the next step is, if M is the midpoint of PQ, find the locus of M. So let's come back to the diagram, the midpoint. So in any of these locus questions, right? So the first step in any locus question is to actually find the coordinates first. Of M. Okay, so just going back to the one with the diagram. So we're finding the midpoint of PQ. So P being 2P, P squared, being 2Q, Q squared. All right, so the midpoint is equals to, applying the midpoint formula, and then simplify. All right, so that's the coordinate of the midpoint. And then now we want to find the locus, meaning you need to find the Cartesian equation that corresponds with those coordinates. So we'll start with the fact that this is your x and y coordinate, right? So that means, so let me just write out the second step. So the second step is to find the locus. Okay, so x is equals to p plus q, y is equals to p squared plus q squared on 2. So the most common way to eliminate the parameter, when I say eliminate the parameter, simply means get rid of p and q across their expression, so you only have an xy expression. Okay, So in these cases, this is a 2-parameter question involving 2 parameters, P and Q. You use the perfect square to assist you. So I'll show you what I mean by that. So you square this first. Expand. And quite often there will be a condition that links P and Q together. And in this case, it's -4. So let's sub in -4. So P squared plus Q squared minus 8. Okay, so that means P squared plus Q squared is X squared plus 8 if you move the 8 to the other side. All right, so once you've done that, then we're going to take the Y coordinate, just multiply the 2 across first, okay, and sort of sub them in. So that's 1, that's 2, sub 1 into 2, yeah, because they're both expressions for P squared plus Q squared, so they're now linked together. So X squared plus 8 is equals to 2Y. I'll just turn that into a standard parabola form. And that's it. So if you are asked to describe this locus, for example, you will say that this is a parabola, concave up parabola specifically, with vertex 0, 4, and then a focal length you can just work out based on the fact that's 2. So that will be, so 4a would equal, I'll do that quickly. So 4a is equals to 2, so the focal length is a half. Okay, so you can say it has a focal length of a half. All right, so that's more or less it. Let's have a very quick summary in terms of what happened in this question. So the very first part is just using the information, the chord PQ subtends a right angle at the origin. So to show that PQ is -4, we studied the gradient of OP, the gradient of OQ, which is P on 2, Q on 2. And since they are perpendicular, so they multiply to -1. So the two things should multiply to -1, and that will produce your condition. The second part, to find the midpoint. So the midpoint of PQ, you apply the midpoint formula first. And then to find the locus, so x is equals to p plus q, y is equals to that. The key point to linking them together is to square the x coordinate, substitute the fact that PQ is -4 back in there, and then sort of sub them into one another, and you'll be able to link it together. And you see the final expression here. The final expression has no P's and Q's in it. Yeah, that's when you know you've got it all done. No P's and Q's, just X and Y. All right, so let's take a look at another type of question. Moving on, exercise 2. So in this case, we've got 2 points show that the equation of the tangent is blah. All right, so that's just a pretty standard stuff, very similar to what we were doing right at the beginning. So let's just very quickly hammer that out. So remember, the first step is find the gradient of the tangent. So we are going to start with the equation and differentiate it first. And sub x equals to 2p because we're working with that point, yeah? So y dash is equals to 2p on 2, which is p. So that means the gradient of the tangent is p. Okay, so now we are going to apply gradient of p, 0.2p, p squared, into the point gradient formula. Expand. Okay, so that's it. All right, so when you see one of these questions, it should be very, very standard procedure. All right, moving on. We want to show that the coordinate of t, which is the intersection of the tangent, is given by that. So just to show you visually what we're working with. So we've got 2 points. Okay, so we're trying to find that point. Now, a very common way to frame this type of question in the recent 2 years with the reference shape these days is kind of like this. They will just go find the coordinates of the point T, which is the intersection of the tangents of P and Q, without the preceding part that asks you to prove it. So I get a lot of questions. Does that mean I still need to derive it? Well, the answer is no, because the questions about the intersection, what you can do is just quote directly from the reference sheet and say, okay, this is the equation of the tangent from the reference sheet, blah and blah. We're just going to solve it simultaneously. So that's what you should do. Now, I may have forgot to mention this at the beginning, but if you go to our website, so actually I'll just do that very, very quickly. So if you go to our website, this is where all the resources are. So you will find that there are resources on our website as well for this module. Yes, so if you go to today's lesson, lesson 4. So the student book, you can use that to watch along with this live video if you were not aware of it. And there was the practice set. Now you might find the practice set incredibly helpful. They're all based on real exam questions. Yeah. So have a look at that. It's got fully worked solutions. And I think that's a very good pointer in terms of some of the more recent questions that come up and how you should address them. All right, so heading back to this question here. So we already have the tangent to P. So from 1 tangent to P is y is px minus p squared. Okay, so now you don't have to derive it again. So you can just go similarly. Tangent to Q is y is equal to qx minus q squared. Okay. To find the intersection, solve simultaneously. Move all the x's to one side. Difference of 2 squares. So they cancel. So x is p plus q. Okay. All right. So then y coordinates, sub that into one of these equations. Expand. Cancels. So just pq. All right. So that's it. All right. Nice and easy. Moving on. Given this condition, find the equation of the locus of t. Now this part is unusual, and I think that's probably why I picked it to show you guys. Usually it's like the previous one, you know, you have the perfect squares and then you're just trying to link it together. But this time the condition is like a strange connection between P and Q. So what I'm going to do is copy the coordinates from before first. Okay, so that's what we're trying to do, or trying to work with. And X, in other words, is equals to P plus Q. Y is equals to PQ. And what you're really looking for here is something that links P plus Q and PQ together. So that's sort of the filter in which we should see this condition. So coming back to analyze the condition, now the first obvious thing that jumps out at me is if you make this one fraction, right? So I'm just going to make a common denominator first. Okay, you see how once I make it one fraction, you see P plus Q and PQ, which is perfect because you know what they respectively are equal to. So X is P plus Q, so just sub X in there. And Y is PQ, so Y in there. So X is equals to 2Y, or in other words, Y equals to a half X. That means the locus of T, if that condition was true, it's a straight line. That's what this is saying. All right, so that's it. It's a little bit unusual, but it's good to push yourself to see unusual things so you're ready for them when they come up. So let's do a very quick summary. All right, so the first part is just very standard stuff. It's all about finding the equation of the tangent. So you go through derivative, the gradient at that specific point, and then point gradient formula. And then the second one, finding the intersection. So you've got the tangent at P derived from before, and then you can for Q just by replacing the parameter with Q, and then solve it simultaneously. X is P plus Q, sub it back into one of them, Y is PQ, hence that's the point. And then finally, to find the locus, meaning eliminate the parameters, get rid of your P's and Q's. How do we do that? Very simple. So X is P plus Q, Y is PQ. Use the condition they've given you here and just sub it into the condition and you'll get the result. And that's it. All right, so the next one, we have 2 points, P and Q, whose coordinates are that? We want to find the equation of the chord PQ. Now we've I've kind of shown you right at the beginning as a part of the standard results. So let's take this opportunity and do this again. All right, so the chord PQ. So I won't draw a fancy diagram, but basically you have 2 points, right? Let's think about what we have. You have 2 points, 2AP, AP square, and another point, 2AQ, AQ square. And you're trying to find the line joining these 2 points. So you go with your 2 steps, gradient. So gradient formula first. So y1 minus y2 over x1 minus x2. Factorize. And then the A and the P minus Q cancels out. Okay, P plus Q on 2. Second step, point gradient formula. Okay, so point gradient formula, very simple. So point gradient. And remember, the trick here is to keep this all together when you expand it, yeah, into the second bracket. And then leave that first part intact. Expand. And minus AP squared cancels. So y is equals to that equation. All right, pretty standard. Moving on. Show that if the chord PQ passes through the focus, then PQ is equals to -1. So very common draw straight lines today. Okay, there we go. All right, so the key condition here is PQ passes through the focus. So how do we use that condition? It's very, very simple, okay? So since PQ passes through the focus 0A, then the focus should satisfy the equation of PQ. All right, so let's take the equation of PQ first. So that's from the prior part. Okay, and we're going to sub 0A into it. All right, so let's do that. All right, so PQ is -1. That is it. All right, finally, exercise 3. X is the midpoint of the focal chord PQ. All right, T lies on the directrix such that XT is perpendicular to the directrix. W is the midpoint of XT. Find the locus of W. I think this third part is not hard, just confusing. So this is where you absolutely need a diagram to be able to figure out what are you talking about here? What is this midpoint and what? One step at a time. All right, so we've got X. Sorry, let's start P. So P is 2AP, AP square. Q is 2AQ, AQ square. Okay, so let's read this carefully. X is the midpoint of the focal chord PQ. Okay, so let's draw in X first, so it's the midpoint. T lies on the directrix such that XT is perpendicular to the directrix. So let's draw in the directrix. All right, so that's T, perpendicular. Okay, and W is the midpoint of XT. Find the locus of W. So in any question, locus question, you need to find the coordinate of the point you're looking for first. So there should be a couple of steps here. So we'll find X first, which is the midpoint of PQ. All right, so I'm just going to apply the midpoint formula to the coordinates PQ. All right, so the 2 cancelled out, and then I might just factorize it. All right, that's it. So x has the coordinates a, p plus q, a on 2, p squared plus q squared. All right, so t is directly below x, so it should have the same x coordinate, and the y coordinate is minus a. So by the same logic, w is lying on a vertical line, so at the least it should have the same. Even if you apply the midpoint formula, you'll get the same x coordinate. Now the y coordinate, we'll work it out using the midpoint formula. So it's a on 2, p squared plus q squared, minus a, all over 2. Right, on 4. So that's it. All right, so now that we've got the coordinate of w, we're not done yet. We still need to find the locus. So let's see if I have more space. No. Okay, so I'll just need to add a new. All right, so right now, let me just rewrite the coordinates for w. Right, so that's the coordinates of w. Another critical thing, because we are eliminating the parameter process, so you need something that links p and q together. So pq is minus 1. All right, so we're using that as well. All right, so firstly, that's your x and that's your y, right? So x is equals to a p plus q square. Oops, not square, no square. I'm about to square it. Okay, and we'll look at the y component very soon. So the first step is to square this thing, so we can create some p squares and q squares. Now pq is minus 1, so let's sub that in. So that means p squared plus q squared is equals to x squared on a squared plus 2. All right, so let's have a look at y. So y is equals to that. Okay, pretty much we can sub it in actually. I'll just multiply the 4 across. All right, so let's call that 1. Let's call that 2. Sub 1 into 2. And then the 2a cancels out. Right, so therefore x squared equals to 4ay. So what do you notice? This is the equation of the original parabola. So of this parabola, okay? So I haven't flicked back to the original question yet, but that's just basically the parabola, okay? And if you look at the diagram, it looks actually roughly right. The midpoint does look like it's going to sit on the parabola. Okay, so it's good that the diagram confirms with our working and everything seemed to work out. So let's summarize what we've done in this question. So this question, we've got 2 points standard parabola. The first step was to find the equation of the chord, which we did by a very standard coordinate geometry process, which is gradient formula. Find the gradient and then point gradient formula, and then you'll get to the equation. That's the first step. Now, the second step is the specific condition to this question is that it's a focal chord, meaning it passes through the focus. So it should satisfy the equation of the chord. So we sub straight in there, and you will be able to get PQ is -1. And this is something you should probably remember. Yeah? Very, very standard proof. Finally, if X is the midpoint of the focal chord, so X is the midpoint, T is such that XT is perpendicular to the directrix and W is the midpoint of XT. Couple of steps here. First, find the midpoint of X, so midpoint formula, vertical below. So same X coordinate, Y coordinate is -a because of the directrix. And W has the same X coordinate because it's on a vertical line between X and T. And the Y coordinate, you can just use the midpoint formula, which is what I've done here. Then to find the locus, eliminate the parameters P and Q. First, I've taken X is equals to A times P plus Q, square both sides, got an expression for P squared plus Q squared. And in between, PQ has been substituted with -1. Second step is to then take the Y coordinate and use that as a way to sub it back into the Y coordinates. So it's linking your X and Y coordinates together. That's what the P squared plus Q squared is for. So sub it back in, and then it simplifies into X squared equals to 4AY, which is the parabola. All right, so that is it for this question. Let's have a look at one final question. All right, so this one is going to be interesting. The intersection of normal is one of those notoriously difficult to do, especially if you don't remember how to manipulate the algebra. It's not hard, it's just a little bit messy and gets very confusing as you work through it. But once you know how to do it, it should be pretty easy. All right, so we've got 2 points on the parabola. Now, I would say this question, if it was written in the recent last 2 years, they probably won't even refer to that. They'll just go, show me that the normal is that. And then you take these equations from the reference sheet. Yeah, so just be aware that's how you approach it, even if they don't mention the equations. All right, so I've kept it simple. I've highlighted for you, you need to consider the equations of the normals. So let's take a look at how we deduce that first part. I hope this is enough room. Let's see. All right, so we've got X. All right, so we've got these two equations. So I'm going to solve them simultaneously through elimination. I am going to do 1 minus 2. So x minus x, 0. Py minus qy. 2ap minus 2aq. ap cubed minus aq cubed. All right, that's it. Then I'm going to, our objective here, I know it gets very confusing for you. It's like P's, Q's everywhere. We are looking for y. All right, that's our objective. And then I'm going to just factorize them in their pairs. This one, you have to further factorize using the difference of 2 cubes, which is on the reference sheet, by the way. So if you get a little bit stuck, you don't have to remember it. Just take it from the reference sheet. All right, so the key point here is if I divide everything by P minus Q, there you go. Okay, and then to get it to look like that, just take out the A. That's it. Yeah, P squared plus PQ plus Q squared plus 2. Yeah. All right. So then from here, it should be much easier. We just sub the Y coordinate back into one of them. Okay, so let's say 1. So X plus PY is this entire thing. So A. Equals to 2AP plus APQ. All right, so just to clarify, I should have done that in a different color. Hold on, yeah, I will do it in a different color so you know what I've done. So that blue bit is the substitution of Y. Yeah, so that blue bit is what's meant to be Y in the original expression. Okay, and Y is this thing. All right, expand. Cancel. And then move that to the other side. And then factorize. And that's it. So therefore, the point R is so it's just a little bit tedious algebraically, but apart from that, I wouldn't say it's incredibly difficult. All right, moving on. I gave myself an extra page, I just noticed. All right, so the equation of the chord PQ is given by that. We don't need to show this, so perfect, we'll leave it. If the chord PQ passes through 0A, show that PQ is minus 1. We've done that actually very similar in the previous question, so let's just sub the point, the focus, 0A, into the chord PQ. That's it. Okay, so let me copy the chord equation first. All right, sub in that point. All right, so PQ is minus 1. That's it. Finally, find the locus of R if the chord PQ passes through 0A. So that's just basically asking us to combine the two conditions. So let's copy the coordinates first. And the condition from the prior part is PQ is minus 1 if it passes through 0A. All right, so same idea as any locus question. You start with the fact that X represents the X coordinate here. And since PQ is minus 1, let's replace PQ with minus 1. So that's AP plus Q. And the next step I want to do is square everything. Why I want to do that is I want components involving P square and Q square, just like the some of the other ones we've looked at today. And then PQ is -1, so I'm going to sub it in again. So that means, fit it somewhere, there we go. P square plus Q square is equal to X square on A square plus 2. All right, so then let's work on the Y coordinate. So Y coordinate, P square plus PQ plus Q square plus 2. PQ is -1. P square plus Q square, let's dump the Y coordinate. Continue up here. So move the 3A to the other side. That's it. So I've just arranged it into the standard parabola formula, but that's the locus. So if you have to describe it, we just describe it as a parabola with so vertex 0, 3A, and then you can just work out the focal length based on the value here. All right, so let's summarize what we've done in this question. All right, so the question basically is broken into 3 parts. You asked to find the intersection of the normals, P and Q, and then you asked to show the conditions specific to a focal chord, and then we're finding the locus of R. So to find the point R, which is this point here, we take the 2 equations of the normals, solve it simultaneously. I've done it through elimination, so I'm subtracting everything. And then the key point is remembering to factorize that using the difference of 2 cubes. And then once you've got that, factorize everything, you'll be able to get to the Y coordinate. Once you've done that, you sub this back into one of the equations. So replace Y with that expression, which is that next step here. 2 of the terms cancels out, you're left with 2, and then factorize and you'll get to it. Next step, you've seen this proof before. If you don't need to show the chord, that actually makes things a lot easier. You just sub the point straight into the chord and you'll get PQ is -1. Then finally, it's about using that special relationship and the XY coordinate to get to the final answer. So firstly, I sub -1 straight in there. So it simplifies to something like that. Square everything, expand, replace PQ with -1 again. So you get an expression for P square plus Q square. Then you repeat on the other side. So Y is equals to that. And then you simplify. So wherever I see PQ, I keep subbing -1. P square plus Q square can be replaced with X square on A square plus 2. So that's what I've done here. And then simplify, and then you get to the locus. And that is it. So hopefully you found this helpful. Now, I know sometimes I do go through things quite quickly, and as this is a live session, you might need to pause it. So it might be worthwhile to rewatch the uploaded version, especially if you're having trouble following. And I'll say the best way to learn parametrics is take the initial triggers and hints I tell you at the beginning of each question. I will say, do this, do that, do this, right? So just try doing those things and compare it to my answer. That would be the easiest way to learn some of this stuff. And after you've done it a while, you realize it's actually the same stuff over and over again. So it's scary at the beginning, but it's the same pattern. So hopefully you found this helpful. Feel free to post any questions of your own, by the way. You can ask questions about this live lessons, or you can ask questions more broadly about any topic that, with assessments coming up. Yeah, feel free to join our discussion group. So just going back to the Facebook page. So you go to Facebook, type in Pinnacle Live discussion group, that will come up. So feel free to use that as your resources. I'll definitely be checking that. If you have any topic suggestions, go for it. And all the learning material I showed you from before is on our website. So please take a look. You'll find it incredibly helpful. And that's it for today. Thank you for your time.